Next task that we will consider is the vibration of rotating disc. First of all, we need to calculate stresses of centrifugal forces. We will create geometry in Design Modeler, select XY plane and go to the sketching. Set the units of millimeters. And next go to the dimensions. So this is a section of the disk. Return to the modeling, select sketch and create a revolve operation. Select axis X and direction normal, and angle of rotation is full circle. So we get this geometry. Save the project and close Design Modeler. Next, go to the mesh. First of all, let's create the mesh by default parameters. Right click to the mesh and generate. Number of nodes is about 1600. We should reduce mesh element. Let's set element size is about 5 millimeters and generate mesh. This mesh is better than previous. Number of nodes is 34,000. This value is bigger than limits of student version, so we need to reduce number of nodes. For example, we can increase element size is about 6 millimeters and generate mesh. Number of nodes is about 22,000. Also, we can improve the mesh by using additional options. We should to change some option. For example, use adaptive sizing. Select no and select capture proximity, and proximity mean size is about 2 millimeters. Right click to mesh and generate. Unfortunately, this mesh is not acceptable for us because we don't fit in a limit of the cells number. So we need to change mesh option. We can look at the mesh in section by using section plane. So we can to increase element size and reduce number of elements. I change the mesh parameter by this. Max element size is 12 millimeters. Proximity mean size is 6 millimeters, and number cells across gap is 2. But in this situation I get the next result. Number of nodes is about 46,000. This quantity is bigger than limitation of student version. We can also use different mesh method, for example multi-zone method. Right click to the mesh and select method. Select multi-zone method, mapped mesh type, hexa and prism, and generate mesh. This is a finished result of the mesh. Number of nodes is about 10,000. If you want to use tetrahedron mesh, you should to consider only half disk to reduce number of elements. So in these tasks we will consider this hex and prism mesh with multi-zone method. And next we will apply a loads and rotational velocity. Insert rotational velocity. By components, rotational velocity is 10,000 revolution per minute. Multiple by p and divide to 30. Angular velocity is about 1046 radian per second. And we should to specify fixed support in this in hub surface and solve the task. Total deformation is about 277 micrometers. Maximum equivalent stress is about 244 megapascal. And minimum safety factor on the edge is about 1. But this is a not true result because of edge. True result is on the hub section. Like this, about this value. This is a true result of safety factor. Save the project, and next we will consider model analysis to evaluate natural frequency of this disk. Close static structural, right click to the solution and select transfer data to new model. Save the project and go to setup. First we need to repeat calculation of static structural. You can check the results and go to the model analysis. Max number of mod to find is 6 and solve. In this task we get large deflection, so we need to set our model. Go to the static structural, select analysis settings, choose a large deflection and click to on. Repeat the calculation. And go to model analysis. In the solution we can add deformation, for example for mod number 1. And in the similar way add deformation about other mods. Mod number 6, 5, 4, 3, and evaluate all result. So we get different forms of vibration. This is the natural frequencies of our geometry. Because stresses is very big, we have big number of mods in the low frequencies. If we reduce forces, for example, if we reduce rotational velocity, natural frequency of these disks will change depending on forces. You can look at the vibration forms. This is the plate vibration. This is a bending vibration. This is also bending vibration. This is a axial vibration. This is also plate vibration in different ways. This is a radial vibration. So the problem of the strength and vibration of the disk is over, and thank you for your attention. Goodbye.